Okay, this is part 2 of our Algebra 1 midterm review. So section 2, functions, domain, and range. So at the top here we have some tips saying domain are x values, range is y values, and another tip to find domain from a graph, read left to right. To find range, read bottom to top. So number 8 is determine if the relation, and it has a set of coordinates, is a function. So a function is something where each input has exactly one output. One output. So what this means is for every input value we have, which input is our x values and output is y. So every single x value has to have exactly one output value. So think of that vending machine example where, say, you press a button for, I don't know, Twix. If you press a button for Twix, you should only get Twix, right? But if you happen to get Twix and, say, Hershey's, that doesn't make sense. That's not a function. Again, that would be a happy thing because then you'd get something for free. But logically, you press the Twix button, you get a Twix, and not a Twix and a Hershey's. So this scenario that I just drew up here would not be a function. So I'm gonna erase that. So we need to look at our set of coordinates and look at our x values specifically. So we have 2, 3, 5, 1, 2, -4, and 7, 9. We have two values of 2, 2, 3, and 2, -4. So since 2 goes to 3 and 2 goes to -4, each input does not have one output. That input of 2 has two outputs. So that is not a function. Specifically because our input has two outputs. Has two different outputs. All right, so let us move on to number 9. We're going to evaluate f of x equals -3x plus 12 for x equals -2, 0, and 4. So this is asking us to do 3 different things. So our first one, we're going to evaluate f of -2 is equal to -3 times -2 plus 12. Because what it's asking for is it wants our x value to be -2, meaning we plug in -2 into each x we see. So instead of f of x, we write f of -2. And instead of -3 times x, we do -3 times -2. So, and I'm going to draw a little line here because it's asking for 3 different numbers, 0 and 4. So it wants x equals 0 and x equals 4 as well. So 3 answers here. So f of -2 is equal to -3 times -2. So that's 6 plus 12. That is equal to 18. So this is saying that f of, I almost put 12. F of -2 is equal to 18. So we solved that part. And now we will solve the second part. Sorry. We have f of 0 is equal to -3 times 0 plus 12. So -3 times 0 is just 0, and then we bring down our plus 12. So we are going to get an answer of 12, meaning that f of 0 is equal to 12. So that's our second part. And then our third, hopefully you can see the pattern. We're writing f of 4 now is equal to -3 times 4 plus 12. -3 times 4 is -12. And then we bring down our plus 12 here. Negative 12 plus 12, that's just 0. So f of 4 is equal to 0. All right. 10 is really similar. This time it's only asking us to find one value, and it's asking it in a slightly different way. Instead of saying x equals 10, it's saying find f of 10. So what this means is that we are going to replace every value of x for 10. So I'm going to draw a little arrow. So we're going to do f of 10 is equal to 5 times 10 minus 9. So 5 times 10 is 50 minus 9. That is equal to 41. So f of 10 is equal to 41. For number 11, is the graph of a vertical line a function? So we know a function is each input has to have exactly one output. And on a graph, that means for every x value, we should only have one different y value. A vertical line is straight up and down, right? And on a graph, think of our axis. We have the x-axis here, and the y-axis here. So for every single value of x, we need to be on a different part of y. But if it's a vertical line, like say that vertical line is on x equals 0, it's going to touch every single point on that y-axis, meaning that is not a function. This is better known as the vertical line test, meaning if you put a vertical line through an equation on a graph and it touches it more than once, it is not a function. So this is no. This fails the vertical line test. So I'm going to kind of branch off from number 11 to give you a different example. So say if I showed you a graph that looked like this little u here, is that a function? What you do is you just draw a straight line through it. Since it only touches at one point, that means this is a function. So this would be a function. And then even another example here, if I give you a line that looks like, I don't know, like this, and you draw a straight line through it, that touches twice, right? It touches here and it touches there. So since this touches 2 times, this is not a function. So those are some other visual examples for you. All right, and here's another one. Identify whether this table represents a function. So they listed the table off just like this. Sometimes it might look like this. You'd have x and y. You'd have 1, 2, 3, 4. And this y is 2, 2, 5, 7. Right? That's what this is saying. So our function, does each x value go to its own y value? So 1 goes to 2, 2 goes to 2, 3 goes to 5, 4 goes to 7. Yes, every x value does have one output value. It's okay if the output values are the same. So this is a yes. Each input, which is x value, corresponds to exactly one output. To exactly one output, which is our y value. So if you want to use the vending machine example again, this is like saying like, oh, I have 2 buttons that say Twix, right? You know, sometimes you go to a vending machine and there's a whole bunch of the same button that says water, just because there's that high of a demand for water. So if our two buttons of Twix both give out a Twix, that's okay. All right, 13, write a function rule for the pattern. We have x increases by 1 and y increases by 4, starting at y equals 3. So x increases by 1. That is trying to say that we're going to the right by 1. Y increases by 4. We go up 4. And we start at y equals 3. Starting at y equals 3 is our y-intercept. And if we have a function that goes over by 1 and up by 4, that is our slope of rise over run, which is 4 over 1, which is 4. So if we have a y-intercept of 3 and a slope of 4, our function, f of x, is going to be 4x plus 3. I'm using f of x because it calls for a function rule. So f of x equals 4x plus 3. This is in our y equals mx plus b format. So that is our answer. 14 is another one where we have to plug in a number into x. Find f of negative 5 given f of x equals 2x squared minus x plus 1. So we're going to plug in negative 5 into this x here that's being squared and into that x there, because you have to plug it into every single x. So f of negative 5 is equal to 2 times negative 5 squared minus negative 5 plus 1. The parentheses are important because we have a negative in our formula already, but the number they want us to plug in is also negative. So you're going to be dealing with a lot of double negatives here. So let's bring it down. Negative 5 squared is negative 5 times negative 5, which is 25. So we're going to have 2 times 25 minus a negative 5. That turns into a plus 5. And then we have this little plus 1. So 2 times 25 is 50 plus 5 plus 1. So 50 plus 5 plus 1, that is 56. So f of negative 5 is equal to a positive 56. Moving on to our next page, describe the domain of a word problem involving the number of cars in a parking lot. So this one is very vague because it doesn't give us any numbers to work with. It just says number of cars in a parking lot. So we need to think number of cars that can't be a decimal, right? You can't have half of a car. Or at least in this scenario, we're not going to have half of a car. So number of cars, we're going to have whole numbers. Only going to have whole numbers in a parking lot. We can't have, like, think of the number of cars. Like, what range of numbers can we have here? Sorry, maybe I shouldn't use the word range because we're talking about domain. But what set of numbers can we have here, right? There can be no cars in a parking lot, and there can also be, I don't know, however many. Doesn't specify that this parking lot has a capacity, but also there can't be negative cars in the parking lot. So this is going to be whole numbers. And since it's saying domain, we're going to say x can be greater than or equal to 0. And this is our answer. Whole numbers where x is greater than or equal to 0. All right, and 16 is state the domain and the range of the graph shown below. So this graph, it's a little hard to see, but we do have little arrows that I'm drawing here. So those arrows are important because this graph doesn't stop. That's what the arrows indicate, is that some parts of this graph are going to keep going, and that's important. So our domain, as a reminder, our domain are our x values, and our range are our y values. So let's do our domain first. So domain. So when we read domain, we always look from the left side over here to the right side. Just the x values. So we will only be looking at these numbers that I just highlighted. So the smallest x value, we're going to follow. I'm going to highlight to show where I am pointing. We're following this as far left as it can possibly go, which that's keeps going, right? That's going to keep going on and on and on and on. So since it keeps going on and on and on, the left side of our domain is going to be negative infinity. I'm going to put a comma. I'm also going to put an x here. So we have x, negative infinity, and then on the right side, it looks like our graph also just keeps going on and on to the right forever and ever and ever. So that means the right side is positive infinity. So your domain is either going to look like this, where you have an x dash, or an up and down line, negative infinity to infinity, or it may also be called all real numbers. Either one is correct. Sometimes the multiple choice options will give you the one with the negative infinity to positive infinity. Sometimes it will say all real numbers. You'll have to know that those two mean the same thing. So that is our domain. And now I'm going to erase the orange that I have highlighted so that we can look at our range. All right. So our range, that is going to be the smallest y value all the way up to the largest y value. So our smallest y value is down here at -8, right? It doesn't go any further down, specifically our graph, right? Like our function doesn't go any further down than -8. So we have -8. And then it looks like we also just keep going up and up and up and up and up forever and ever and ever. So we have -8 to infinity, but we're not used to writing it like this. So one way to write range is the way I have it here. Or in Algebra 1 specifically, we are going to write it like y is greater than or equal to -8. Because y can be larger than or equal to that -8 value. That could be any number bigger than that. So that would be our range. And that's the end of section 2, and we'll be moving on to section 3.